Okay, so here's a lesson for section 8.1, applying the Pythagorean Theorem. Before we actually do some questions applying the Pythagorean Theorem, I just want to quickly review what the Pythagorean Theorem is. So before we get started, hopefully you've gone to jensenmath.ca and you have printed off the lesson so you can follow along and fill it in as we go through. And then after, you can also get the worksheet from there to practice what we've learned. Okay, so I just want to start off quickly reviewing, what is the Pythagorean Theorem? When you hear the words Pythagorean Theorem, the first thing that should come to your mind is right triangles. What is a right triangle? A right triangle is a triangle that has one angle that's equal to 90 degrees. So, for example, if I have a triangle, I know it's a right triangle if one of the angles is equal to 90 degrees. Well, how can I tell if any of these angles are equal to exactly 90 degrees? The way you can tell is to label a 90-degree angle, there will always be a little square by the angle. That will tell you that, in fact, this angle right here of the triangle is a 90-degree angle, or a right angle. That tells you that this triangle is a right triangle. Why are right triangles important? With Pythagorean Theorem, well, Pythagorean Theorem only works when working with right triangles. And what Pythagorean Theorem does is allow you to find a missing side length of a right triangle when given the other two side lengths. So now, let's talk a little bit more about right triangles. There's one more important thing we have to remember about right triangles before I remind you about the Pythagorean Theorem. So you have to remember that right triangles have one side that we call the hypotenuse. So how can you tell which of these three sides is the hypotenuse? Well, hopefully you remember the hypotenuse. Well, there's two ways you can tell which side is the hypotenuse. The first way you can remember is the hypotenuse is always the longest side of the right triangle. There's another way you can tell. So if the side lengths of the right triangle aren't labeled, and you can't tell which one is the longest, well, the hypotenuse is always the side across from the right angle, or opposite from the right angle. So this side is my hypotenuse. Okay, so two ways to tell which side is the hypotenuse. Way number one, it's the longest side of the right triangle. Way number two, it's the side across from or opposite from the right angle. So find your right angle, so look for that little square. That'll tell you where the right angle is, and the hypotenuse is always across from that right angle. Okay, now let's talk about Pythagorean Theorem. Before I remind you about Pythagorean Theorem, let me remind you how we label the sides of a right triangle. You always label the hypotenuse. We use the letter C to label the hypotenuse. So this is side C. Now the other two sides, the two shorter sides, we always label them with A and B. Now it doesn't matter which one of the shorter sides is A, which one is B. It could be labeled like that, or it could be labeled like this. It doesn't matter, just as long as you label the two shorter sides with A and B, and the longer side, the hypotenuse, with C. Okay, and we call side C the hypotenuse, side A and side B are called the legs of a right triangle. So let me just fill in that information. That information will go down here. So in a right triangle, we use the letters A and B to represent the two shorter sides, or the legs, of a right triangle, and we use the letter C to represent the longest side, or the hypotenuse, of the right triangle. Okay, now what does Pythagorean Theorem tell us? Let's just quickly, I'm just going to try and zoom in here. Let's just quickly look at this triangle in the top right here. Okay, look at this diagram. Let's focus our attention on the triangle in the middle of this diagram here. Okay, so I've got my right triangle. I can tell it's a right triangle because there's this little square here. And I've labeled the triangle with sides A, B, and C. I've labeled the legs, A and B. So the legs are the two shorter sides. They've been labeled A and B. And I've labeled the hypotenuse, the side across from the right angle, with side C. What does Pythagorean Theorem tell me? Pythagorean Theorem tells me that the sum of the squares of the two shorter sides equals the square of the longer side. Okay, so let me show you. I'll use this diagram to try and help you understand what that means. So if I have I've got my triangle, side length A, side length B, side length C. If I draw a square with the side length A, the area of that square is A squared. If I draw a square with side length B, the area of that square is B squared. If I draw a square with side length C, the area of that square is C squared. What Pythagorean Theorem tells me that if I add the area of this square to the area of this square, it will equal the area of this square. So what Pythagorean Theorem tells me is that A squared plus b squared equals c squared. Or, equivalently, c squared equals a squared plus b squared, however you would like to write it. I will always use a squared plus b squared equals c squared. Okay, now let's actually use Pythagorean Theorem. So Pythagorean Theorem tells us that a squared plus b squared equals c squared. And remember, this only works for right triangles. Okay, so let's read this question. I'll zoom in on it a bit. Okay. Example 1. The advertised size of a computer or television screen is actually the length of the diagonal of the screen. So whenever you see a computer screen or a television advertised, let's say you're buying a TV that is 50 inches in size, what that's telling you is that the diagonal, or the length from one corner to the other corner of the TV, is actually 50 inches. So I've got a TV here, and I've got two lengths given to me. I know this side length here is 30 inches, and I know this side length here is 22.5 inches. I want to actually know the length of this diagonal that I've highlighted here. What's the length of that diagonal? So I know what this TV would be advertised as size-wise. Okay, so let's figure out the length of that diagonal. What I have to first do is I have to realize that there's a right triangle embedded in here. So I have a right triangle. I'll just highlight the right triangle just so you can see it. So there's my diagonal. Here's this side. And here's this side. So what I do have, in fact, here is a right triangle. I'll label my right angle using, let me just get rid of this highlighter. I'll label my right angle with a little square to show you where the right angle is. So hopefully you can see it. So here's my right angle right here. Okay. So I've got a right triangle, and I'm given two of the side lengths. I'm given this side is 30 inches, and this side is 22.5 inches. I want to find the other side length, which is the diagonal of the TV screen, which will tell me the size of the TV screen. So let's figure that out. Let me first label my triangle with sides A, B, and C so I can tell which side is which. I always like to label my hypotenuse first. I know the hypotenuse is always the side across from the right angle. So this right here is side C. My other two sides are my legs, and I label those with A and B. It doesn't matter which one is A and which one is B. So I'll just label this side A and this side B. Now I'm going to use Pythagorean Theorem and fill in the information I know, and then solve for the unknown side length. So let's fill in what I know. Pythagorean Theorem tells me that a squared plus b squared equals c squared, or the sum of the squares of the legs is equal to the square of the hypotenuse. So let's plug it in. A, I know, is 30. So 30 squared plus b squared, b is 22.5, 22.5 squared is equal to c squared. And I don't know the length of c, but that's my only unknown piece of information. I'll be able to solve this equation for that unknown piece of information. Now all I have to do is plug this in on my calculator. What is 30 squared plus 22.5 squared? You could evaluate those separately as long as you follow the correct order of operations and evaluate the exponents first and then add them together. Or you could just type in on your calculator, as long as you have a calculator that will do the correct order of operations. You can just type in 30 squared plus 22.5 squared, and you get 1,406.25 equals c squared. Now, just keep in mind right now, I shouldn't round that answer yet. You should never round until you get to your final answer. That way you get an accurate result. So I have 1,406.25 equals c squared. I don't want to know what c squared is equal to. I want to know what c is equal to. So I now have to isolate the c. Right now, c is being squared. To move that square to the other side, do the opposite of squaring, which is square rooting. So I must square root the other side. 1406.25 equals c. So I now have to take the square root of 1406.25, and I get the answer 37.5 equals c. So the question asked me to determine the length of the diagonal. I did that. I'll write my answer. The length of the diagonal is 37.5, and don't forget your units, we're working in inches. 37.5 inches. Good, there's our first question with Pythagorean Theorem done. So in this question, I was given the length of both of the legs, and we solved for the hypotenuse. Let's do another example where we'll do the same thing. Okay. So when Lori swims laps in her rectangular pool, let me zoom in on this for you so you can see it better. Okay. When Lori swims laps in her rectangular pool. So I got my rectangular pool just off to the side here. Hopefully you can see that. She decides to swim along the diagonal so that she doesn't have to turn around as often. Find the distance Lori travels by swimming once along the diagonal. Round your answer to the nearest tenth. So hopefully you can see these lengths. They're a little bit small. So basically it tells me that this length of the pool is equal to 11.6 meters. And it tells me this length of the pool is equal to 5.2 meters. Hopefully you can see that now. The question is asking me if Lori swims the diagonal length of the pool, so from here to here, what is that length? So first thing I'm going to do is I'm going to notice that I have a right triangle here. I have my right angle right here, and I'll just highlight my triangle so you can see it. So here's my triangle, here to here to here. There's the triangle that I'm working with. And once again, it's given me two side lengths, and the two side lengths that it's given me are the two legs, and it's asking me to find the length of the diagonal, which is the hypotenuse. I can tell that the diagonal is my hypotenuse because it is across from the right angle. I label the hypotenuse with side C, I label my legs with side A and side B. Doesn't matter which one is A, doesn't matter which one is B, as long as the legs are labeled A and B. So, if you remember, Pythagorean Theorem tells us that A squared plus B squared equals C squared. So it's given us two of the three pieces of information. We can solve for the third. So it's given us A and B, plug in that information. So I have 5.2 squared plus my B value is 11.6, so plus 11.6 squared. I know that's equal to C squared. I don't know C. That's what I'm going to try and solve for because C is the diagonal, and that's what it's asking me to find, the length of the diagonal. So, once again, do 5.2 squared plus 11.6 squared. So last time we did that all at once using the calculator. Now let's do this one step by step. So remember, order of operation tells us to do exponents before we do any addition. So let's evaluate. What is 5.2 squared? 5.2 squared gives me 27.04. And remember, don't round yet. Don't round until you get to your final answer. Now I need to add, what's 11.6 squared? Well, 11.6 squared is 134.56. Now I can add these two things together. Okay, so now you'll add the two of them together, and you'll get 161.6 is equal to C squared. Now remember, I don't want the answer for just C. I don't want to know what C squared is equal to. I want to know what C is equal to. So don't forget to take your last step and actually isolate C. So right now I have on the right C squared. To isolate the C, do the opposite of squaring it, which is square rooting it. So I must square root the other side and get 161.6 under the square root sign is equal to C. So now to get my answer for C, I must actually evaluate what is the square root of 161.6. And now it asks me to round my answer to the nearest tenth, so now I can actually round my final answer, and I get 12.712, 19887. I can round that to just 12.7 to the nearest tenth. Remember, tenth means one decimal place. So 12.7. So the length of C is 12.7. Now let's actually answer the question that it asked us. It said, find the distance Lori travels by swimming once along the diagonal. So, how I'll answer this. I'll say Lori swims 12.7, and don't forget your units. We're in meters, so 12.7 meters when she travels along the diagonal. Good. Okay, so we've done two questions where for each of the questions we knew the lengths of both of the legs and we solved for the hypotenuse. Now let's do another type of question where you'll know one of the legs, you'll know the hypotenuse, you'll have to solve for the other leg. So there's going to be a little bit of rearranging involved when we're solving for the unknown length in this question. So let's read the question. Let me zoom in on it again. So Example 3. Jenna is changing a light bulb. She rests a 4-meter ladder against a vertical wall so that its base is 1.4 meters from the wall. How high up the wall does the top of the ladder reach? Round to the nearest tenth of a meter. So, I've got a little diagram here that kind of shows me what's going on, but it doesn't have the lengths labeled. So I need to make sure I've read the question very carefully so I know where the pieces of information go in this right triangle that has been drawn for me here. So I've got a right triangle. I know it's a right triangle because I see this little square here labeling the right angle. Now let's read the question again. It says, Jenna is changing a light bulb. She rests a 4-meter ladder against the vertical wall. So I can see my vertical wall. Here's my vertical wall. And she rests a ladder against the wall. So this right here must be my ladder. And she tells me that that ladder is 4 meters long. So I'm going to label that side 4 meters. It also says that the base is 1.4 meters from the wall. So if I look at my diagram, the base of the ladder is 1.4 meters from the wall. So this side length here, that side length must be 1.4 meters. Let me see if I can get myself some more room here. This side length is 1.4 meters. And what it's asking me to figure out, it says how high up the wall, or it says all, it should say wall, does the top of the ladder reach? So it's asking me to figure out what is the length from here to here. So it's asking me to figure out this leg of this triangle. Okay, so let me first label my triangle with A, B, and C, so we know what we have here. Remember, the hypotenuse is always C, and the hypotenuse is always across from the right angle, so this is side C, and my legs are A and B. So it doesn't matter which one is which. I'll label this one A, I'll label this side B. Okay, so this question is a bit different from the other ones that we did because, in this case, we know our hypotenuse. We know the length of the hypotenuse is 4. We know one of the legs. One of the legs is 1.4. We don't know the other leg. We're going to have to solve for that. Well, we'll still be able to use Pythagorean Theorem. We'll still be able to use the formula a squared plus b squared equals c squared. But we will have to rearrange it a bit. Now, we could rearrange it now. We know we're going to have to solve for a, so I could rearrange it now by moving the b squared to the other side. And I'd have a squared equals c squared minus b squared. That'll make it a bit easier. Or I could plug everything in first and then rearrange after. And I'll do that to show you what that looks like. So, plug in everything that you know. There are 3 variables in the equation. I know 2 of them. I'll be able to solve for the third. I don't know a, so I can't plug in for a, so I'll leave a squared there. I do know b. b is 1.4, so I have 1.4 squared is equal to c squared, and c has a length of 4, so 4 squared. Now what I have to do, I can move the 1.4 squared to the other side, or what I could do, I can evaluate these squared values now, because I know order of operations tells me to evaluate the exponents before adding or subtracting. So, okay, let's figure out what is 1.4 squared. I figure 1.4 squared is equal to 1.96. So I'll change that to a 1.96. And equals 4 squared, I know 4 squared is 16. Now I'm going to need to solve for a, so I'm going to have to isolate the a. First, isolate the a squared by moving the 1.96 to the other side. Since on the left I'm adding 1.96, on the right I must subtract 1.96. And now you can value, okay, what is 16 minus 1.96? And we get 14.04. So I know a squared is equal to 14.04. But what is a equal to? Don't forget to isolate the a. We must square root the other side. Square root of 14.04. And that gives me 3.7469. Now does it tell me what I should round it to? Round to the nearest tenth. Okay, so that means round to 1 decimal place. So my answer was 3.74. So that means since the digit next to the 10th column, so in the 100th column, the digit is less than 5, I must round. I must not round up, okay? So I have to leave it at 3.7. So 3.7, and we're in meters. Good, so that tells us, let's look at what the question asks us. It asks us to find how far up the wall does the ladder reach. So it was asking me to find A, and I found out that was 3.7 meters. So the ladder reaches 3.7 meters up the wall. Good, so now I've answered that question. I think we have maybe one, maybe two more questions to do. Let's do a question where we're going to, I think we have two more questions to do, another application of the Pythagorean Theorem. To do this question, you're going to have to remember what I've put in here. You're going to have to remember how to find the area of a triangle. So remember, the area of a triangle equals half times base times height, or you could write it as base times height divided by 2, whichever you prefer. And you have to know if we have a right triangle. Let me just draw one here. If I've got a right triangle, here's my right angle. Here's my A, my B, my C. Remember, C is always across from the right angle. That's our hypotenuse.
After damage to your home. Within seconds, you'll be speaking to our local claims staff.
And so there's my hypotenuse across from my right angle, side C. You have to know that the legs of the right triangle, are the base and the height. Okay, so remember, area of a triangle is base times height divided by 2. Well, which sides of the right triangle are the base and the height? Well, it's the legs. The legs are always your base and your height. Okay, so base, height. The hypotenuse is never the base or the height. So to find the area of a right triangle, you don't need the hypotenuse. You just need the legs, because the legs are the base and the height. Okay. So let's do example 4. So you'll need all that information to do this example. Calculate the area of the triangular sail on the toy sailboat. Okay, so I've got my sail. It forms a right triangle. Here's my right triangle here. It wants me to find the area of that sail. Remember, to find the area of a right triangle, remember, area equals half times base times height, or base times height divided by 2. So I'm going to need the base and the height of this right triangle. And hopefully you remember the base and the height are the legs of a right triangle. So I'm going to need the length of both of the legs. Let me label this right triangle. I've got my legs, I'll label A and B. And my hypotenuse, which is across from the right angle, is side C. So I need both of the lengths of the legs to determine the area of the triangle. Well, I've only got the length of one of the legs, but I could determine the length of the other leg because I do know the length of the hypotenuse. So remember, Pythagorean theorem tells us a squared plus b squared equals c squared. I know the length of a. That's 8. So 8 squared plus b squared equals c squared. I know c. C is 11. So 8 squared plus b squared equals 11 squared. Well, 8 squared is 64. Plus b squared equals 11 squared is 121. Now let's isolate the b squared. Move the 64 to the other side. I'm going to have to subtract it. So I have 121 minus 64 will give me what b squared is actually equal to. So I know b squared is equal to 57. Now if I want to figure out what b is actually equal to, I must square root the 57. To move that square to the other side, I have to square root it. So the square root of 57 is 7.5. So my b value equals 7.5, and I'm in centimeters. Okay. So, and I've rounded that to the nearest tenth. Okay. Now, if I want to find the area of this this triangle, what I have to do, I have to remember the formula: area equals base times height divided by 2. And remember, the base and the height of a right triangle are the legs. I have the length of both of the legs. Length A, that can be my base or my height, doesn't matter. And length B, that can be the other one, the base or the height. Okay, so my base and my height are my legs. My legs have lengths of 8 and 7.5, which I just determined using Pythagorean Theorem. I must then divide that answer by 2. So what I have, if I do 8 times 7.5 divided by 2, that will give me 30, and my area, I know I'm going to be in units squared, so centimeters squared. So the area of that sail is 30 centimeters squared. So the question asked me to find the length, I did all of the steps in one here. I did give you room over here to find the area. I did that on this slide as well, but that's fine. So it asked me to calculate the area of the sail. I'll write my final answer on the next slide. The area of the sail is 30 centimeters squared. Good. One more example. I like this example. Zeke drives from his house in Geometropolis to his cottage in Decimal Point. He drives 64 kilometers east and then 135 kilometers north. How much travel distance will he save when he drives along the new square root expressway? Okay, so lots of fun math terms in that example. Here's a diagram that shows exactly what it's talking about to help you visualize it. So basically, when Zeke goes from his house to his cottage, what he does, he starts here, starts in Geometropolis, he drives east 64 kilometers, and then goes directly north 135 kilometers. Going directly east and directly north, that will form a nice 90-degree angle. So basically, that's how he normally drives to his cottage. But they're adding a new square root expressway, which is going to go directly from Geometropolis to Decimal Point. So as you can see, this forms a nice, perfect right triangle. And we know for right triangles, a squared plus b squared equals c squared. Pythagorean Theorem will allow us to find the length of an unknown side. And what do I have? I'm given one side. I'm given a second side. I could find this, the third side. Let's figure out what does the question ask me to find first. The question is asking me to find how much travel distance will he save when he drives along the new square root expressway. So how far does he normally drive? Well, he normally drives 64 kilometers east, and then 135 kilometers north. So normally he drives 64 plus 135. So normally he drives 199 kilometers. How much shorter is it going to be when he takes the new square root expressway, which is right here? Well, let's figure out the length of that side and see how much less that is than 199. That'll tell us how much distance he is saving. So let's figure out the length of that side. Well, I've got my right triangle. The new square root expressway is across in the right angle, so that's my C, my hypotenuse, and my legs are sides A and side B. Let's plug in what we know into Pythagorean Theorem. I know 64 squared plus 135 squared equals c squared. Now you can plug in 64 squared plus 135 squared on your calculator and get 22,321 is equal to c squared. Now isolate the c by square rooting the other side. I get the square root of 22,321 is equal to c, and now I'll actually evaluate that and round it to the nearest, does it tell me? No, I'll just round to the nearest tenth, so I'll get c equals 149.4. Good, so now what I want to do, okay, so if he takes the new square root expressway, he's only going to travel 149.4 kilometers. The old way he traveled, when he went east and then north, he traveled 199. So how much distance does he save? Distance saved, let's calculate that. So he used to drive 199. With the new square root expressway, he will drive 149.4. Let's subtract that from the 199 to determine how much distance he's actually going to save. So we'll do 199 minus 149.4, and we'll get 49.6. So now let's actually make sure, remember our units were in kilometers here. Now let's actually make sure we answer the question fully. So how much travel distance will he save? He will save 49.6 kilometers when he takes the new expressway. Good. And that's it. That's it for this lesson, I believe. Make sure you download the worksheet from jensenmath.ca, try it out, and make sure you can apply the Pythagorean Theorem, and let me know if you have any questions.